Oh well, never mind. So, welcome to the stream, everybody, and let's continue where we left off. So, uh, last time we left off with our beloved steering rack. I still think the suspension itself needs some work. For example, if we compress it a little bit, it's maybe a little too squishy for my taste. I don't know. We'll see once it's on the road. Yeah, we'll see. Some optimizations are still possible. I have an idea. For example, I have an idea how to make this kinda. I don't know if better, but if I manage to find a two stud bar, that would be great. Then we could do something, you know. Then we could. Where? Here it is. Okay. So then we could fix this. If I get a two stud bar or something that's gonna fit in here, then we could do the following. That's one of my ideas. So we could do this, but we still need to support the upper structure so it doesn't pivot around this part here. Because we don't want this to happen. So we need to fix this to this, but we can't because this is just a one stud. So what we can do, I hope, I haven't tried this, I'm trying this now on stream for the first time. So we could do the following. We could do this. Hey Dennis. And this. And now we can fix this properly. There. I need one more connector. Because I'm curious if this actually works or if this is just garbage. So I can discard it and then we can move on to what we were planning to do all along. This and this. And it's here. Yeah, but not really. No, it's an idea, but not really. Sadly, we have to remain with the solution that we have until Lego produces a connector with a two stud axle. But yeah, okay, never mind. Moving on. So today we are gonna do the firewall ish, you know. Problem is I have not done any calculations for this, and yeah, let's recall. Let's get the um, the file that yeah, the file that I have up, and let's make some calculations. Where is it? Where is it? Come on, this can't be this hard. No. Ah, yeah, here it is. Stupid me. There we go. Come on, load. Okay. Yeah. Okay. Um. The. Okay. Yeah. Well, I prefer to do some calculations. You know. So, um, the firewall will calculate the firewall by the outside. Um, so by the outside attachment points of the A pillars. I think that's gonna be best. Approximately, of course. We're gonna approximate this because this is not exact science. Of course. I forgot to take note how wide it is. 20 pixels. Where I have paint box. No, I need this. Come on, where's the, no. 520. So, where's the sheet? I mean, sorry if this is a bit boring, but I should have done this before the stream, but I'm lazy. So, we have firewall. I don't have to write this down. 520. Where's the calculator? 520 divided by 27. So it's 19 studs, which is great. 19 studs is great. Okay. 19 studs is the firewall. Okay. You know, that's good information. So between the axles, we have between the axles we have space between the wheel wells, between wheel wells. So 520 sorry, 500 divided by 27 means 18.5. Right, so 18.5. But it's gonna be right. So this is 19 as well. Okay. And then of course the wheelbase we already have the number. Come on. We have the number for the wheelbase, which is 28 studs, I believe. Let's check. Wheelbase is 28 studs. Yeah, wheelbase is 28 studs. So these are the numbers that we need today. So that's come on, where is it? So this is 28. 28. This is all we need. Okay. Oh, you know, Wyatt, it's 1 to 10. That's the scale we are building it. So let's return to our chassis here. So in order for us to do this, since we now know the dimensions, we are gonna build ourselves a rig, basically. Since we know the distance here between the centers, and we know how basically how long the part of the body has to be between the wheel wells, we can do the floor without having the rear section done yet. And the rear section we are gonna start tomorrow, not tomorrow, on Friday. On Friday we start the rear section. So we probably are gonna have a rolling chassis by this time next week, probably. So something that we can work with. Okay. So how big is this? This is, if I'm not mistaken, 15 studs exactly. So 19 studs is what we need between these two. And I'm still yet undecided if we're gonna have the engine. So if we are gonna have both mirrored, so like this, exactly mirrored, or if the rear is gonna be attached like this and the front like this. I don't know yet. But the rear is gonna be a lot simpler because this section here where the steering rack is not gonna be there, and we are not gonna have steering, so it's gonna be simpler still. So just, and the lower arms are not gonna be able to pivot, or if we allow them to pivot, it's gonna be really slight. Maybe we should do this. So we have basically a ball joint here and a A-arm here, and the A-arm may allow just minimal movements, just so that we can have maybe a steering link that will allow us to have some bump steer, because in the rear we can have bump steer. So yeah, we need a jig. Let me get some material out. So we need 28 studs. We already have one jig for basically for the width of the car, and we're gonna expand on this. Basically, we're gonna use this jig to see, this is the width of the car that we have. Now we're gonna build a second one for the rear wheels, and since we know where the center is, then we can throw this away for the time being, and then we can build this to the measurements, and then we have the platform on which the car needs to sit, just so we can constantly check during the building process if we are on the right track. Okay. Enough frames so we can use these. there. I'm building two identical ones, so you know I don't have to think too much, because thinking is hard already. Okay. And another one there, and we have two identical ones. Okay, so now we mark the centers. This is gonna be important. So now the first measurement we need to make is these two centers need to have basically we need a 29 long lift arm. Hey Christian, because the centers of those are 28 studs apart. So 28 studs, we can make 2 15s are 30, 31, and then 28. Yeah, we'll do it like this. It's easier. Okay. So what am I gonna use? This maybe. So this. So this is 31, and if I put them together, let's do 15, it's 30. So 30 minus 2 is 28, and we should be here. That should be the wheelbase. So basically we have 28 between the centers of the wheels, but since we're using the whole stud, we need like this. We need it to be 29 studs. Yeah. Oh God, Mr. Cat, what do you want? Yes. Mr. Cat wants attention, I think. Huh, Mr. Cat? Yeah. I know. Well, I think he wants food. And I'm a monster by not feeding him. Hey, Ken. So, okay, that's the rig, basically. So, here's the front suspension, and the rear suspension goes in here. And now we need to determine, so we need 19 studs of 19 studs of bodywork between the front and rear. 19 studs, how do I recreate this best? So it's 15 plus 4, right? 15 plus 4, and it has to be symmetrical. Exactly like this. Exactly like this. Okay, so I'm gonna mark the this and this. And this is gonna be our measurement, because if I don't mark it, I'm gonna forget it, of course. This is basically where our bodywork may sit. So if we look at it from the top, yeah. So it's kind of like this, you know. Front suspension, rear suspension, that's the amount of bodywork we can have between both axles. Yeah, pretty much that's it. It's not gonna be big. No, I mean, it's not gonna be that small, actually, now that I'm looking at it. And I think we're gonna have problems here. But maybe I have overdone this a little bit. So it's 19 studs. It's 5 plus 5 is 10 plus 4 is 14. I mean, the measurements do check out. They do check out. So I don't know. Maybe it's gonna be okay. But you have to keep in mind that the wheels that we are gonna use are gonna be larger than this. And we are gonna adjust things accordingly. I have to buy wheels as soon as possible, because you know, without the wheels, it's really hard. For the Charger, I bought the wheels as soon as I could as well, because it's difficult. Anyway, and we know that the firewall width also well, the maximum width of the firewall can also be 19 studs, which looking at this looks excessive, but the track itself is 24 studs, I think, ish, you know. Let me check the file. Come on, where is it? Wheelbase length with no, the width is 23 studs. Okay, so we have the firewall is okay. So we are gonna make the firewall not 19 studs. We're gonna make the firewall 17 as a maximum, because otherwise we will have trouble with the doors and stuff. So 17 is the maximum we're gonna go for the firewall. And we have to mark it as well. Okay, so just so I can visualize, because I'm someone, if you haven't noticed yet, I really like to visualize stuff like this in jigs and what's the word? Help me. Templates. Yeah, templates. I really like templates, you know. It helps me visualize where things need to go. Yeah. So looking at the wheels and the maximum width of the car, and knowing, while looking at pictures of the car, that we have like yeah, I mean, even here, you know, I'm gonna go 15 studs, because you have to imagine that we have doors here, and we have actually quite large. So the door is basically not recessed. We have fender flares basically that are that make the car much wider in front and rear. So the actual body of the car is much slimmer. So we're gonna go with 15. That's gonna be more than enough for what we need. 15 studs is gonna be what we're gonna go for with the width of the firewall. Um, yeah. Now, of course, while doing the firewall, we have to consider a few things that have not been a problem until this point. So regulations say that we have to have a working steering wheel in the cabin, and of course a driver's seat and stuff. You know, of course we're gonna have open double doors because they will allow us access, you know, inside and stuff. Um, and yeah, and of course, as with all of our cars, the firewall is one of the main structures because we have a roof, of course, that like in the Sierra is gonna be, you know, a major load-bearing structure. But of course, unlike in the Sierra, everything is much squarer here. So we can have well, I hope the angles are gonna be favorable with us, so we can have some cookie cutter solutions where we don't have to have some extremely custom angles. Yes, this car is the Audi S1 Quattro. Um, so, the height of the firewall should be, according to blueprints, 8.5 studs. So we're gonna make it 9 studs. So from the bottom of the car, which is this, up until the top part of the bonnet. So the highest part of the bonnet where it meets the windscreen should be 9 studs, according to blueprints. 8.5. So we are going to make it 9 studs. And this part here, the mount for the shock absorbers, is going to be hidden in a very small and subtle power bulge on the hood. So when the car is, you know, all done, this is going to be hardly noticeable. And I think some street versions of the S1 had a power bulge on the hood, or, you know, sorts. I even think, wait, does this? Yeah, it's not gonna look wrong, you know. It's gonna be instantly recognizable, but it's gonna have a slight hump on the hood. You know, nobody's gonna notice because everything else is gonna be correct and flat, and I think we can be forgiven. Otherwise, we just cannot do the McPherson setup. So, and we want it, obviously. Okay, so let's mount this and see where our limits are. Okay. So if we are gonna use this, we have to, and we should probably, because it's in a race car, it's inconsequential if there's a hole. Maybe it makes things easier accessible, or we can make a hatch here. You know, you open it and you can pull the Buwis unit out of it, or, you know, something. Like in, you know, like in a toy RC car. But this is nice because it's gonna be light, because the heaviest parts of the car are gonna be the front and rear sections with the gearboxes and the motors. So we have to make everything else as light as possible. But yeah, we need to somehow mount this. And as you can see here, since we can have bodywork here, but the firewall is gonna be recessed because of the steering rack. So the firewall, the structure cannot be further forward than this, sadly. But oh well, you know, what can you do? And this spot, I'm wondering, what if? Of course, we're gonna have to replace the pin here with something, and then we are going to mount this part here, which is kind of rare. I would mount this part here, like so, because then you can see the pinholes. Then we could mount the pinholes here, like this, and this would perfectly mount. Yay! Then we would have this mounted there. Yeah. Okay, so we have to make some changes here. This guy here is gonna be replaced with this, I think. Let's see what the steering says about this. So, because this is gonna give us more meat here, to which we can then attach this part here, and it's gonna be fine. I hope. So now that we know how this goes together, we can kind of dismantle it, and for now we don't need this. Yeah, basically we need to dismantle most of this. I mean, it was just a placeholder anyway, but what can we do? Come on. Okay. So, and this gives us an opportunity to maybe redesign this, because I don't think this is very optimal, to say the least. So this is gonna be placed like this here. No, wait, this is the wrong part. What? Don't I? Yeah, I do. Okay. I do have. So first, let's see if the steering rack agrees with our choice of lift arm. So that if it doesn't, we don't waste time. Come on. Okay. Yeah. No problem. Yeah, there's no clearance issues, so, and this part here is the same. Sorry, this part here is the same as it was, so I was only concerned about the triangle part here, so it's fine. Yeah, this is fine, and we need where was it? Okay. So we have now two choices. We can mount this as low as possible here, and have this part here mounted above it, or the other way around. So we can have this part here. What should we do? I'm very conflicted about what to do. But I guess I would probably prefer this setup here. This would give us, you know, not necessarily more space inside, but I think it's gonna give us more flexibility. We can still change it, of course. Oh. There. So we would have it like this, and now we can mount it, you know, to this, and it would be like that. This would be the floor of our car, kind of. I think. Okay. Come on. Ah, okay. But since I have this out, I need to do something to this. I think we can make it like that. Here. And this part here is gonna connect, you know, to the floor here. To be precise, yeah, exactly. And this is like 7 studs. Okay. Now let's engineer this. Well, ground clearance is it's gonna be fine. You know, it's, you know, ground clearance is gonna be to scale. That's all that I can say. It's gonna be to scale, and that's gonna have to be enough. The good part here is that we are actually saving parts and making it actually lighter, which I like. Okay. This is just a placeholder, but you know. Okay, now how to fit this in as painless as possible. Since we won't necessarily want to remove it. We need, this is a what? This is a 12 would a 9er. 9er would be fine. Yeah, 9er would be fine. Where did this go? Okay. Okay. And here for the top one, I'm probably gonna want to use something else. For example, this, you know, so it stays in place. And I'm going to move this in place like that. Okay, that didn't go as planned. I miscalculated here. Now, of course, that I have this in, now you won't go out. Yeah, of course. Of course. A classic. Okay. So, I need a 7 stud in here. There. Woohoo! This is pretty solid, actually. Now we need basically just to have some A-pillars sprouting out from this, connecting to the roof, and this is gonna be a pretty solid car with actually very little in structure. Not bad. Not bad. Okay. Firewall. We said, well, 15 studs basically. 15 studs. I mean, for all intents and purposes, if I made this smaller, that wouldn't be better. Wouldn't be bad. It's just for easier access. Okay. See, no bumps there. Yep, the wheels stay absolutely flat on the floor when cornering. This is nice. Well, it's not needed actually. You know, this is because you see what's happening here. See this? Actually, this part here is moving. I mean, yeah, we have to reinforce this, of course. We have to reinforce this. Probably, yeah, we probably should replace this part here with a longer lift arm. So it would be, it's a 5er, 5 and 3 is 8. No, that's not gonna happen. So a 7 stud lift arm that would connect to this and then also to these two. Yeah, that's more likely. So the 7 stud lift arm would then connect to all 3 studs here, and this would prevent, you know, this from happening, because the pivot point is here on this axle, this red axle. And then, of course, once you have the firewall and A pillars, of course, that connect to the roof and the whole roof, you get the same situation as in the Sierra, where the roof is basically a very integral part of the structure of the car. That you really realize when once you take the roof off, you realize how fundamental to the stability of the whole car the roof is. So that's why I hate convertibles. I mean, one of the reasons why I hate convertibles. Yeah. So before we go in here and change these parts, let's consider where the driver is gonna sit, so we can design the steering wheel. So since this is a very small car, the driver is probably gonna be pretty close to the center of the car. I would say, where do I have it? Let me find. Okay, so let's pretend this is the driver's seat. Let's pretend for a second. So the driver would be sitting somewhere here, and the steering wheel is gonna be somewhere here, something like this. And as we have to have the steering wheel actually be connected to the steering rack. Now, my idea would be that we have the steering wheel connected to this. So this goes then directly to the servo, and this would be really the easiest part, because having this connected to the steering rack would be kind of pointless, you know. And we have precedents that Lego does it as well. So we can have then, you know, since we would do this with an axle and or stuff, no, we would probably use this here, here, you know, and then we would have an axle going over there, and on the steering rack, steering axle, we would have another one. this, and probably directly like this. This would be then our steer. Oh, right. Needs to be a double. Let's see if I actually estimated this correct. Yeah, yeah. See, this would be our steering rack. Over-engineered, of course, but you get it. So this would be our steering. I think it's even in the right height. So we just have to figure out how to angle this, and it's gonna be fine. And the steering, the servo is gonna be, I guess, here in the back or down there, acting on this. I would preferably the servo would be here, connected directly here, as close to the steering rack as possible. And then on the passenger side, we would have the Buis unit. So you just open the passenger door and you can, you know, press on and disconnect stuff and whatever. Ish, you know. I have to get it to package it, but there's gonna be enough room here to do it. We can even have the Buis unit here, so that it's as low as possible because of center of gravity and stuff, and you know, kinda. But you know, that's my idea for a for the steering. It's the easiest way and the least painful one, so we don't have to do crazy stuff in the firewall that's unnecessary, because this is perfectly fine. I see no reason why this would not be like this. Okay. This said and done, let's dismantle this to make some changes before we move on to the A-pillars. Not to the A-pillars, to the roof, because we need to know the height of the roof, where the A-pillar actually is, and then we can design this. Yeah, so more measurements are going to be required. Whatever. Let's get this done. Okay. So obviously we need to do something with this. This cannot remain as it is. So how is this done? Okay. Stop wiggling. Okay. So we're gonna replace this. Just let me adjust a few settings on the cooling of my computer, because I think it's running maybe a little bit hot. Let's see. Okay. Yeah, it's gonna increase RPMs a little bit. I hope it doesn't affect the stream too much, but it's I think it's too hot. Hey, Jason, welcome to the stream. Okay, I hope this isn't too audible. Of course. Over engineering at its finest. Where is the steering rack stuff? Ah, here it is. Okay. So obviously I want to change this so that I have better access to the gear. There. And something that I am gonna do here, simply because I want reliability, it's gonna be this. I absolutely do not want this to get dislodged. So I'm gonna do this. So no matter what happens, the gear here cannot fly off. And then I need to turn it around. Okay, so this has to go in first. There. There. And now we are gonna use this here. Yeah. In hopes that it's gonna be better than before. And who would have thought? It is better than before. Now the weakest link is here. See? So some triangulation, like Ben suggested, will happen, I think. Yeah. But this is better than before. Much better. Yeah. We have omitted a few parts, which is always good. I still think that we have to kind of omit even more parts, but you know, not quite yet. Once we are happy with everything, we need to go through this and see if we can simplify stuff and throw parts out. But anyway, okay. So what we have to do here now? Why do I use 2L friction pins, black but not 1.5 non-friction pins. I don't quite understand what you mean. Those are all friction pins. Every single one of those pins is friction pin. I would not want to use non-friction pins. All of this has to be friction. Of course, you want to use friction pins unless you want stuff to move, of course. I use friction pins on bodywork exclusively because I don't want stuff to rotate. I want stuff to be as fixed as possible. So I use I also don't use axles if I can avoid it, because axles are not good for bodywork because they allow movement, and unless it's an axle that connects two axle holes, never an axle that connects pinholes. That's the philosophy here. So if you want structural rigidity, of course, then you want absolutely an axle hole and pin in pinhole, preferably a friction pin. Okay, so more calculations need to be done, I'm afraid. So before we can do the A-pillars, we need to know how high the roof needs to be, how wide the roof needs to be, and where the roof line ends here in relation to the front wheel. So that's going to be our measurement point. And then we can properly guesstimate the A-pillars. So let's return to our measuring. So this time we want to know this point. So first 334 pixels. Which is 334 divided by 27. 334 divided by 27 is 12.3 studs. Okay, 12.3 studs. Let's say it's gonna be 12. Maybe 13. We'll see. Okay, so 12. What's the height of the roof? First, what's the width of the roof? That's important. 70. 370 divided by 27 is 13 pixels. Okay, 13.7 ish, but I think we're gonna go with 13. 13.7 because we're not gonna have a even stud roof. We're gonna have an odd stud roof with, I think. But I'm gonna put 0.7 just if maybe an even stud roof is gonna be preferable. I don't know, but I think we want odd studs. And the bottom part of the windscreen is, just when we are here measuring stuff, is 500 pixels. Yeah, 500 pixels, and that's, I think we already measured. 500 divided by 27 is 18.5. Yeah, so 19-ish. Yeah, okay, we have this measurement. Okay, now the only measurement we still need is height. What's the height of the roof? Height of the roof is come on, okay, here. So and the height of the roof I'm measuring from the bottom of the car. So the top part not go any higher than this 390 pixels. Where is it? 390 pixels. Oh, come on. 390 divided by 27 is so 14.4. Let's say 14. 14.4 or 4.5. Okay, half a step. Okay, just so we need to, if we need to refer back to it. Okay, so now we do have all of the measurements that we need to construct our dummy roof. You know, some contraption here that mimics, you know, our roof, I guess, in order for us to be able to construct the frame of the front windscreen, which of course is one of the major structural elements. Yeah, I mean, I'm gonna use stuff like this because it's gonna make my life easier. The more big elements I use, the better. So we said 14 is the height. This is 15. And this is gonna be 14. Okay. So this is the top of our roof. Okay. Now this. So we need to go 12 studs from the center of the wheel. 12 studs ish, you know, since we can't go, it would be basically we would then have to have the roof kind of half a stud, so let's say 12 studs from here. Yeah, you know, the dimensions cannot be 100% accurate anyway, especially not at this scale. At the scale of the Sierra we can be more accurate, but here we're gonna go with what we have here. So this is the center of the wheel, and this is 12. So 12 is here. These are 12 studs. Theoretically, we would go half a stud because this would be 12 studs. And we're gonna move the roof. Well, move. It's a hard word, but we're gonna move the attachment point of the roof here. So we have 1, 2, 3, 4. Okay, we have 4, which gives us exactly this. This. Where's the other one? Here. This. If I don't make sense, please do tell me. Okay. We are completely ignoring the rest of the car here. It's at the moment this is not important. So 13 studs is this. So this is how wide the roof should be here, give or take. You know, kind of 13.7, and it probably will be 13.7 because we're gonna probably have a plate here or something that's gonna make it a little bit wider. So I'm gonna tuck this in. Okay. So so theoretically, this is the attachment point for our A-pillars. Theoretically, we're gonna move this stuff a little bit around because I'm obviously taking parts that are way too big. I just want to get the feel of where things are gonna be. Now, something like this is gonna be, yeah, we're gonna have to change this. This is not okay. Probably to something like this. Yeah, this is better. At least, you know, that we get a feel for the geometry. At this point, I'm not concerned about this, how exactly it's connected. My concern right now is to establish the four corners of the windscreen, so that we know where to build stuff from. So now that we have this, we are missing one more component. We are missing the point where these attach. So where exactly is the A pillar? How far away from the front axle is the A pillar? One more measurement that we need to take. One more measurement. And the A pillar is wrong measurement. Yeah, A pillar is exactly the firewall. Exactly, the firewall is where the A pillar needs to attach. So the windscreen frame is it's tiny. It's quite small, and the windscreen, is it? Oh wow, it's even almost. Eyeballing this. Okay, tiny bit. Yeah. And of course, but this is smaller because we have 15 studs. 15 studs of width here. So 13 and 15. No, sorry, 19 studs. Sorry. 19. Yeah, we're gonna go with 17. As we stated before, yeah. this. Okay, so these are our A pillars. I think they're still, it's kinda, I don't know. Looks a bit too wide, maybe. But yeah, we are fixing the A pillars here to this. This is the A pillar. That's weird. I mean, I never worked on something so small before, with all of this, all of these features. So what do we do here? Obviously, these are way too tall. Do I have smaller ones? Wait. I don't. So, how do we do the firewall without spending too much material on it? Because we still need to make up the difference here. And these here are too wide. They are too much. That's a good question here. I don't know. I don't know. See, this is again one of those moments where you basically stare at this. You know, you stare at it for a while, get a few scenarios in your head, what could be done, and then start building. We could use these. They are a proper size. They could be easily attached, and we could try it here, and we can always have stuff attached to this on the other side, you know, for example, just thinking aloud. I do have just 3 left, so we will probably have to do just one side, but you know, something like this, for example. But it's not okay because then I cannot mount anything here on top. So maybe we could use this. This could be possible. Yeah, but we would have to re-engineer the entire pillar. This here I think would be too wide. Maybe not. Maybe not. I'm looking at the blueprints now to guesstimate what we can do, what we're allowed to do, basically, with what we have. I would feel more comfortable if those were one stud further in. But in this setup, they can't be. In this setup, they can't be. But what if we change the setup? You know? What if we change the setup here a little bit? So they would be here instead of that. Okay, but what then? Ooh. It would be possible, but there's of course another problem. So maybe the other problem is that, see, this is, you know, this is the maximum height that we are allowed to use. This is the maximum height, but in order for us to attach the A pillars, we need, as in the Sierra, of course, we need this to be either further inside or further inside, you say. Further inside. What if this is already so much inside the cabin, you know? I would like things to be as close to the wheel, but yeah. This is obviously not possible because it's too wide and too high. If we drop it one frame, it's not too high, but it's too wide. We cannot stack this. Damn it. I'm pretty sure that there is a very nice solution to this, as there always is. But right now I just cannot. You see, it would be perfect as a firewall. So what we have to do here is we have to re-examine the structure that we have here and build it with this in mind. Yeah, and here, of course, you see, here CAD would be really of help, because in CAD you can do several iterations of this without us having to disassemble everything here. Much easier, and of course see the angles here. Not, I mean, we're gonna have to do this anyway. And I'm actually pretty happy with the structure here. This is very sturdy. This is not separating. It's very nice. It even, you know, it's even torsionally very rigid. It's gonna be even, you see, it's gonna be a lot more rigid once the roof is in place. So this is gonna be really stiff, just as we want it, because we want basically the suspension to do all of the work instead of the body. Body needs to be stiff in the suspension. It's gonna be, for the weight, it's probably gonna be stiff enough. And if we have some jumps, you know, if it bottoms up out, we gonna have some skid blocks, if you will, for it to kind of skid on them instead of the plastic. Yeah. So, you know, I have hit here a creative roadblock, and I think we should continue with this in the next stream, because the next 2 days there's not gonna be a stream, and I'm gonna have enough time, now that I see the problem, to digest it and to debate it with probably with Christian and Ben, and let's see what kind of solutions we can come up with, because it's much easier, you know, to do this in the course of a few days. You have more time to think, and we are gonna achieve a better result, I think. This means, of course, that tomorrow afternoon I'm gonna sit here without the stream, and I'm probably gonna be staring at this for an hour before I apply some bricks, or I'm just gonna look at pictures on the computer and see, okay, maybe this, and then I'm gonna try it and see, nah, doesn't work. Yeah. So, wait, you have seen the multi-link suspension, right? Or not? I made a video of it. I mean, I can show it again, but if you want. You mean this here, right? Yeah, I have disconnected the cylinders here because I needed springs. Doesn't matter. I mean, it still works perfectly well without the springs. It's just, you know, it's all bionicle stuff, of course, because I'm allergic to slack. And I wanted things to be like really sturdy. See, things here just don't move. There's no slack in the ball joints. The only slack you see here, this is the slack in the turntable, and this is really sturdy. Yeah. Oh my god. I still like it. The Audi is tiny. See, this is the front suspension of a Dodge Challenger, for example. This is the Audi. The size difference is, you know, kind of, it's silly. How many modded parts does it have? Let's count. Per side, of course. So, first I modified this thing so that it clears the spring. So the spring is in here, and of course this had to clear it, otherwise it would. Then we have here both of these sockets here are modded parts, just as the top one, and I believe, yeah, this one is modded as well. This one is modded as well. It's not just cut off. It's also glued to this lift arm here. This lift arm and this socket here are glued together. Otherwise, there's no chance of this working. And then you see, here, you see all of these arms here. All of this is glued together, because otherwise this would come apart. So this axle is glued into the connector and in the ball joint. This axle is glued in the ball joint and the connector. And this ball joint, this connector, this axle here, and this is also one piece. It's glued together. Otherwise, it wouldn't work. Yeah, and that's it. So that's what? That's 1, 2, 3, 3 modified parts on the hub. And then if you count the arms, they are three arms modified. And here on top, it's this connector here modified. This, of course, is optional depending on what spring setup you do. But you know, I did this. The anti-roll bar is somewhere here. Yeah. For the anti-roll bar, of course, I modified these links, of course. See, I made a 4 stud instead of a 6 stud because, you know, a 6 stud was just too long, and these are mounted to the spring mounts. So basically, it's like the real car. No, even now, I would do it exactly the same. There is no possibility to build this in this fashion without using modified parts, sadly. But yeah, I mean, this is not for, this thing here is separate. This is just a project, you know. This is not for the challenge. This is just a pet project that I made. You know, it's the suspension of the Dodge Challenger, the front suspension of the Dodge Challenger. It has, of course, all of the geometry that needs to be there, you know, so that when the car rolls, it gains camber. You know, it's in the corner, both wheels are perfectly aligned with the road, and you know, stuff like that. It has caster, everything. It's, you know, geometry wise, this is amazing. I really like it, but it's huge. I don't know, it's really huge. It uses non-Lego wheels. I don't know. It is a nice project, but I actually came to appreciate the fact that things, if done exclusively out of Lego, out of unmodified Lego, have their own. They're more valuable, if you know what I mean. They're more valuable because they can be recreated by others. This has no value. I mean, it's interesting, but it has much less value because it cannot be recreated by others. So if I want to make instructions for stuff like this, it's difficult because then I have to teach you how to modify parts and stuff. See, it would have to be a small scale V8, because even this, as big as it is, it's too big. If this was a McPherson suspension, then I think, like in the Mustang, it would be fine, because the LP Power V8 fits in the Mustang without problems. Not here. This would require probably a small scale, a small cylinder V8, you know. Just a second. So, this is the front suspension. The rear suspension is even more elaborate. Oh, really? Yeah. Really? Oh, for fuck's sake. Come on. There. So the rear suspension here is even more elaborate. Of course, it has 5 links as you know, as per standard. It has 5 links. It has the beefed up differential. It has, of course, you see, the toe changes depending on the suspension travel. It has active bump steer, just as the real thing. It's of course very beefy. It's, you know, just as the front, it's extremely sturdy. You know, it's a nice suspension, but at the same time, you know, it is really strong. Downside, of course, of this is that this is heavy. It's pretty heavy, and that's not okay. It's pretty heavy. It's hard to make this this complexity smaller, because you see the arms here are custom. Each arm is a different length, and you see the ball joints here are staggered in the front and down below. See, and I have incorporated here. I don't know if you can see it. You can see the 8880 CV joint. It's very hard to see, and I don't know if you can see it. Yeah, you can see it here. 880 CV joint with the helicopter CV joint seat that has been cut and glued to a wheel adapter. So it's like, this is really beefy. I mean, I haven't dismantled this simply because I think that this is still good and could still be potentially used somewhere else. Well, thing is that if I wanted to do a smaller engine, I need to use the small cylinder engine. The V8 has as few parts as possible. I probably couldn't omit parts without compromising the structural rigidity of the engine. And you know, as with the designs that we do, this is a good sign, because if you have a model there where, or you know, a design where it's hard to take anything away from it without compromising it, that means that you have reached the desired level. You know, if you know what I mean, then it's okay. Yeah, this is very beefy, really nice, and the differential casing really is designed not to be basically indestructible. You know, I even put this here so that this guy here cannot wobble, and the gear here, so the driving gear, is also supported properly, so that really, I mean, this can go nowhere. And it has the beefy CV joints here. It's virtually indestructible. And the differential can be easily removed, of course. Just disconnect this and off it goes. Yeah. No, I am not a friend of motorbikes. I never had much interest in motorbikes. What's this? Dirt. Never had much interest in motorbikes, so yeah. I'm more of a, you know, I'm a car guy, cars and trucks. That's always been my point of interest. Oh. Anyway, that's it for today. As always, thank you for watching. Do join our Discord. I'm always there, of course. If you have any more questions, ask them in the Discord. I'll happily answer them. As said, this needs a creative pause, and on Friday, I hope that we can continue this. Until then, of course, Discord. I do have a yeah, exactly. I do have a Patreon, of course, if you want to support me, because you know Lego is not cheap. And until then, I see you on Friday.